Good morning, guys. We're going to go ahead and let everybody get online. All right, guys. Good morning. I'm going to give you like the first 10 minutes or so to work on your quizzes. If you have any questions about how to access that, let's unmute. You have like the first 10 minutes. So at 9:10, we're going to start notes. Then the other thing is your notes, like the Word document, is on Google Classroom. So you can print it if you want to write on it, or you can like download it so that you can write on it on your computer, or you can pull out a note spiral. Whatever method is going to be easiest for you, you are welcome to do. Okay. So go ahead and do that now for me. You are either working on your quizzes or you are printing off notes if you already did it. Okay. You guys have any questions on that stuff? Anybody?
Ms. Joyner?
Yeah.
Whenever we do the quizzes, do we turn in a screenshot or do we just finish it?
I actually get a report through quizzes. And then another question that somebody asked me yesterday was if you can retake it. That's totally fine. Just like when you do your name, put like Miss Joyner 2 for your second attempt. But I don't care if you want to retake it. That's totally fine.
Thank you.
Okay, you're welcome. Any other questions?
Miss Joyner.
Yeah, what's up, Liam?
Class, 6th period. So, do you have the information for the Google Classroom?
You're in my Google Classroom for 6th period?
I was in Miss Dodgen's class, and they.
Oh, okay, yeah. Hang on one second, I'll pull it up.
Okay.
1 second. And then I'm going to go ahead and just send you the other 2 things that I need you to join as well.
Okay. Were there any assignments that you gave out yesterday?
Just the quizzes that they're all working on right now, but it's over Trig. So I taught them kind of like, Okay, Liam, do you see that info?
There's a 2 right after the first period code. Is that for second period or is that part of the code?
Hang on, let me switch you to my projector audio so that I can hear you. I'm having a little bit of trouble hearing you. Just one sec. Okay, now try one more time.
There's a 2 after the code. Is that part of the code or is that for second period?
The 2 you're talking about on the first period Google Classroom code.
Yep.
The 2 is part of it, so it's 2 YOLCJE.
Got it.
Okay. All right, so it's 9:07. If we don't have any questions on the quiz, we can just go into notes. But if you do have questions, I wanted to honor that from last time that we said we'd do that.
Hello? Can you hear
Yeah,
me?
hi. Yes.
Okay, I have a question in the quizzes.
Okay.
One of the questions told me it told me it was wrong, but like I checked and the one I picked was right, so I'm confused.
Do you happen to remember which question it was?
It said find 5 pi over 3.
Which trig function was it? You said it was.
Find 5 pi over 3.
Okay, let me pull the quiz up real quick and see. Okay, so you said it was something 5 pi over 3. Okay, so sine of 5 pi over 3, you would do your hand thing, so pi thirds would be here, so it'd be root 3 over 2. But, oh, it should be negative. You're totally right. Thank you for pointing that out. Yeah, if you got that one wrong, that is correct. It should have been negative on that answer. Negative root 3 over 2. Okay, that's fixed. So then if you just missed one, I'll give everybody basically like one freebie since that question was wrong. Thank you for pointing that out. Could I have a recording? Yes, Annalie, I did record it and I can send it to you. Will you just remind me after because I don't have it pulled up right now, okay? All right, so if you guys are ready, let's do some notes. Google Classroom code. Yeah, Jasmine. I know I'm like replying to these out loud, sorry. I just sent it to you. Haven't gotten any other questions. The quiz, I think it's due, I think you have until Tuesday. Let me check though. I tried to give you plenty of time just because some people got added to first period pretty late in the game. Let's see. Your due date. I don't know how to check that apparently. 2 days ago. Ooh, I know how to do it. Hang on. Reports. Okay, the deadline is August 25th at 4 o'clock. So August 25th is Tuesday. So that's like basically the next A day that I see you, it's due at the end of that day of school. So it gives you a little bit of time if you need to retry it or whatever, then you can do that. Okay? All right. Let me send this kid the link. Okay, so we are about to start notes. I just want to make sure everyone that has reminded me, I message them back. Hopefully we have everyone. Yeah. So if you have on the classroom, so once you go there, then you should be good. Okay. All right. So we're going to go ahead and start. And then we said that was what, August 25th for the quiz, just so it's in the chat. And then classroom codes. Okay. All right. Hopefully y'all have everything you need. If you don't, we should have time. If you're looking at the notes, they're super long. We're not going to get through all that today. No big deal. We're just going to get through what we get through. Okay. So let's start our notes. After I open okay, can you guys see the paper? Yes? Okay, so we are going to start off talking about limits. So if you were in pre-AP, you may have actually already seen this before. But if you were in regular, some teachers covered it, some didn't. So I'm going to kind of pretend like you've never seen it before ever, and just kind of start from square one. So at the top, which if you are writing in a spiral, I think I said this, but no big deal. Okay, you can just kind of like look at the graph on your thing, but I wouldn't try to like redraw it right now. You can always go back and do that later if that's something that really matters to you, okay? So single-sided limit, you have the limit as x approaches a number c plus f of x equals L, or limit x approach c minus f of x equals L. So write those two things for me first. And then, of course, we'll talk about what they mean. Okay, so the first thing that you wrote down is a right-sided limit. Okay, what this means is as you approach x from the right side, the y values approach L. As you approach x from the right side, y values approach L. Okay? And then this guy over here to the side of that, okay, is what's called a left side limit, which basically means that exact definition is the same, except rather than right side, you would put left side. So I'm going to go ahead and rewrite it, but if you want to abbreviate that, that's fine. Okay, as you approach, oh, hold on, and actually right here, put x equals c. From the left side, the y values approach L. Okay, so here's basically what you're doing. You're going to cut your graph in half and only look at the side that you care about. So for example, if I'm doing number one, and actually I'll give you a sec to write. Okay, hopefully that was enough time. So if I'm doing this first guy here, x is approaching 1, I see the little minus sign. Little minus sign means that it's a left side. So I'm going to cover up from 1 over. This entire part of the graph is gone. And then I'm just going to look and see what my y values are doing as I approach that cutoff point. So as I check my y's here, from the left side, they're approaching a y value of 1. Okay, the type of dot on the end does not matter, okay? Now let's do one from the right side. So I'm going to write here, this is a left. Oops, my pen is dying. Okay, this is a left side. Okay, because of the minus. So then for my plus, I know that's a right side. So rather than having my ruler cover everything bigger than 1, I'm going to have it cover everything less than 1, okay? Now remember, I can't see any of this part of the graph. I mean, you can because my ruler is unfortunately transparent. Okay, but pretend it's not there. Okay, everything under orange is gone. So if I was coming in from the right side, I'd be like, okay, fa la 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 la, jump, fa la 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 la, boom. What am I at? What y value? Okay, 3. So remember that over here, as I kind of trace my graph, my y value is staying right at 3. So if I were to guess what's on the other side of the ruler, I would guess 3. Okay? All right, let's do the next one. So we want to approach x approaching 2. I see my little minus. That means that it's a left side. Remember, if you're doing a left side, you want to cover the right side. Okay, so the plus or minus is telling you what side you're looking at. You're going to cover the other side. So I'm covering the right side of 2. Okay, that means everything under the ruler, it's not even here. And then I'm like, okay, well, what would I guess the y value is on the other side? Well, as I trace my graph, I'm on the little quadratic. Okay, then I jump up here. And then as I approach that line, my y value is staying right there at 3. So I would say my left side limit is 3. Okay? Number 4, I want 2 from the right side. So if I want the right side of 2, I'm going to move my ruler over and I'm going to cover the left side. And then as I trace my graph, remember all this is gone. Okay, bye, it's gone. So as I trace my graph here from the right side, I'm coming closer and closer to x equals 2. My y values are getting closer and closer to y equals 2. So you're looking at what your height is getting closer to as you approach that x value. Okay, so 2 plus, that's a right side. Okay. Okay, I see some chats here. Oh, great, doing attendance. Okay, next question. So I want you in your mind, okay, we're doing 3 from the left and 3 from the right. So 3 from the left, I'm covering this side. And then I'm looking to see, as I trace this graph here, okay, what are my y values getting closer to? Closer and closer to, that's a height of 3. That's my left side limit. Then I'm going to cover from the other side, and I'm going to check 3 over on this side. So as I trace this line, remember this goes up forever and ever. As I trace it closer and closer and closer to x equals 3, my y value is also approaching, you can see. Okay, that's a height of 3. Okay, so I'm going to pause for a second. If you have a question, you can type it in the chat. You can unmute and say it out loud. Do y'all have any questions about that so far? We should be starting off not too crazy. Anything? Okay. All right, so that's called, and if you did have a question, chime in. Oh, wait, you might have one. How do we know if it's a left side limit? Okay, so the answer to that question, this was typed in the chat privately. It's a left side if it has a little minus here, and then it's a right side if it has a little plus sign. Oh my gosh, look how good my nails look. So great, up close. Okay, so hopefully that answers that question. So if it's a minus, it's a left side. If it's a plus, it's a right side. Okay? All right. Yes?
So for question 3, when you approach you're choosing
You're choosing the y value that your y's are getting closer to.
Okay. So that's like 3, not a 2, or not 2.
Okay, so remember though that you're talking about this question, correct?
3.
This one?
Yeah.
This question? Okay. So remember that if you're doing a left side limit, everything on this side of the graph is gone. So I never even see this open dot because it's covered up. So maybe I could like squeeze the ruler over more. But like your actual dot at 2, you're not looking at it. Open, close, you're only tracing where the graph is. So I would say when I'm on the graph here, I'm on that little flat chunk. You're totally ignoring the open or the closed circle. Make sense?
Point value, like for 2,
Yeah, and actually let me make a clarification point. So let's say that the question asked you what f of 2 is. Well, then you would be looking at the dot, right? You would be like, okay, well, f of 2 is open at 2. I don't want that. Then I would say it's 3. So that's referring to a y value, okay? And that is exactly like what you would have learned in Algebra 1, Algebra 2, again in pre-cal. Okay, so let's do the same thing for 1. So for at 1, what would I say f of 1 is? Looking at your graph. And remember, f of 1 is referring to the y value at 1. So I would have these two choices, okay, but then you should have learned, right, that I don't want the open circle. I want the closed circle, so it would be what? Correct. So we understand the difference. F of 1, f of 2, you're looking at the dots. But for limits, you're looking at what's happening next to the dot, not what's happening at the dot. Okay? All right, good job, good job. Okay, so the next thing we're going to talk about is a definite limit. Here's the difference. A one-sided limit, you're only looking at one side of the graph or the other side of the graph. Okay, that's what the little plus or minus means. So if the limit as x approaches c from the right is equal to the limit as x approaches c from the left, then you have what's called a two-sided limit. Okay, so I'll give you a sec to write that down. But basically what it's saying is that if my right side and my left side limit are both equal to the same number, then I can be like, oh, okay, well then that's my limit at that point. And I can take this little plus or minus here, I can remove that and say, well, actually, since the left and rights match each other, I can just pull that off and say it's a two-sided limit. Okay, so let's look at the first example. So notice no little plus or minus. That means the left and rights have to be the same. Well, the limit as I approached 1 from the left side was 1. The limit from the right side was 3. So what I would say about this limit is that it does not exist. Okay, that stands for does not exist. Okay, and so if you remember in Mean Girls, when she goes to the math competition and she's doing the math problem and the answer is, it does not exist. Okay, that's really like a real thing. Okay. Okay, next one. So we want x approaching 2. Well, then I check the left and the right side limits as 2 of 2. We already did those here. Okay, so from the left side, it was 3. From the right side, it was 2. So because those don't agree, I would say DNE does not exist. Okay? Now for number 9, I want x approaching 3. So I check my little one-sided limits over here. And I'm like, oh, well, that one's 3, that one's 3, they're the same. Then I have a limit for this guy. Okay? Can you explain how we know if it's DNE? No worries, Josh, you're fine. Yes, I'll post this on YouTube. Okay, so you know that it's DNE if the left and right sides don't match. So for example here, okay, my left side limit, we did this earlier, my left side limit was 1. Left limit is 1, but my right limit equals, what was it, 3. That is an ugly 3, but you get the idea. So if my left and right limits are not the same, remember that's your condition that you wrote out right here. My left limit needs to be equal to my right limit. Okay, if those match, okay, and they're both equal to whatever this number in the middle is, then that's how I know that my overall limit is also equal to that. Okay? All right, so let's come down to number 10. We want x approaching -2. So if I'm looking at my graph here, remember I have to cover this from the left side, cover from the right side, check and see if they're the same, okay? So let's come up to our graph here. -2 is here, covering it up. If I were to trace my graph on the side that's not covered up, remember this parabola goes on, okay, forever and ever and ever. As I trace this graph towards x equals -2, it looks like it's gonna stop right here, which I don't know if you can see through my ruler, but that's a height of 4. So I'm like, okay, my left side limit is 4. Now let's check the right side limit. So I'm gonna slide my ruler over to here. Remember, I'm cutting the graph off at -2, and then I'm like, well, does the other side of the graph match, right? As I trace here, I would be like, okay, well, if I had to stop at -2, probably I'd be right here. What's that height? 4. So then I would say, okay, well, my left side looks like it was coming to 4. My right side looks like it was coming to 4. Then overall, my limit is 4. Now, that should kind of make sense, right? Because there's no break in the graph there. So if I look at either half, it's like, because it's connected, it doesn't really matter which side I'm looking at because they're connected. Does that make sense? Can you say that one more time? Move it down or up? Sure. Okay, so your next question is going to be to look at the limit as x approaches 0. Okay, and then after that, x approaching 1.5. Okay, so go ahead and do those two for me. I'll leave the graph up a little bit here. Okay, try to do those next two on your own. So x approaching 0. So remember, if x is approaching 0, I'm going to cover one half, look what it's going towards. Cover the other half, look at what it's going towards. Okay? So let's cover this half first. That half of the graph is gone. As I trace my graph here, okay, my y value looks like it stops at 0. Then I slide my ruler over, I'm checking the other side. Okay, crazy stuff going on over here, but remember, I only care about what's happening close to 0. So as I trace this little chunk of graph, as my x gets closer to 0, my y is getting closer to 0 as well. So what that means is my left side limit's 0, my right side limit's 0, they match. So I can say then that this limit with no plus or minus is also 0. Okay? All right, we have one more left after that. We're doing x approaching 1.5. So 1.5 would be here on the graph, right? Exactly halfway between 1 and 2. Okay, so let's do our little thing, right? So I'm going to cover the first half, covering right here. And I'm like, okay, if all of that other side of the graph is gone, I only have the left side. I got crazy jump right here. But as I'm close to 1.5, I only care about this little chunk of graph, right? As I'm on 1.5 and I'm edging closer and closer to it, what are my y values approaching? Well, it's a flat line, so it's just basically staying at a height of 3. So my left side limit is 3, and I slide my ruler over. I'm looking at the other half of 1.5. Crazy little jump here, but remember, I don't care what's going on over there. I care about right next to 1.5 because that's what my X value is approaching. So as I'm on this little chunk right here, I see that my height is also right there at 3.
So Ms. Joyner, if that's
Yes.
you don't have to jump to Zoom.
Can you ask that one more time?
So if that's that we have the link to the graph, not just highlight
Would you mind typing your question? Your audio is a little fuzzy for me.
okay.
Okay, when you have a jump in the graph, is that the only time the definite limit rule doesn't exist? No, there are other cases, for example, like asymptotes and stuff that we're gonna look at in our next example. So I would say if there's a jump in the graph, which actually that's great that you remember that word. If there's a jump or a break in the graph, your left and right side limits are for sure gonna be different. That means your definite limit is for sure going to DNE. But there are other ways that that can happen as well, which we'll talk about in a second. Okay, good question though. All right, let's turn the page. All right, so we got another little graph here. Okay, I'm going to give you a couple not seconds, I always say that. I'll give you a little bit of time to do 1 through 6. Okay, so remember, if it's a minus like this, which side is that? Approaching from the left side or approaching from the right side?
Left.
Okay, good. And if I'm looking at a left side, what am I covering?
The right side.
Yes, okay, perfect. Okay, same for number, what is it, 3. I have a little plus sign. That means it's a right side limit. That means that I'm covering the left side, okay? All right, so I'm going to give you a sec. Ask questions if you have them. You can do it in the chat. You can do it via audio, whatever you want. And let's see if you get it right. I'm the worst at numbering stuff, so yeah, probably you can renumber them on your paper. I literally number everything wrong. It's tragic. Yeah, 1, 3, 5, 4, 5, 6 is the struggle. Okay, so you ready for some Zoom roulette? Avery, the limit as x approaches 2 from the left, what did you put, sis?
1.
That's correct. Good job.
Can you hear
Okay.
me?
Huh?
Did you hear me?
Oh, yeah. Your audio is good.
I'm on my computer. So bad.
Okay, Alec, give me the limit as x approaches 2 from the right.
I got 1 for that one as well.
Okay, so let's check if I'm approaching 2 from the right. Remember, all that graph is gone. So as I trace here, what y value though am I getting closer to from the right side?
2.
Yes, 2. Good. Okay, now, the left side was 1, the right side was 2. So Jocelyn, what is my answer to the next question, x approaching 2? What am I going to put for that? Oh, I did not hear you, but I'm assuming maybe was it, I don't know. Amelia, can you help her out? Hey, baby.
Oh, I thought I'd scare you.
Okay, I'm in the middle of class, so.
Hi. Hi, Miss. Hi.
Okay, sorry. Amelia, what would you put?
I put does not exist.
Perfect, very good. Okay, does not exist because my lefts and rights weren't the same. They have to agree for this to exist, okay? All right, next row, we got 3 from the left. Let's see, where's my mouse? Okay, I don't know who to pick because I can't change my screen. So somebody else. Oh, I found it. Alejandra. Okay, what is my limit as x approaches -3 from the left side?
-2?
Correct. Okay, next person, let's do Molly. Okay, what about -3 from the right-hand side? And then if those two match, that means that this one is going to be -2 as well. So remember, left and right sides match. You have a limit without the plus minus. Okay, but if you need the plus minus and they don't match, then you would have to separate those and say B&E. Okay. So at an endpoint, I want you to think about your endpoints here. Okay, one-sided limits can exist, but a two-sided limit cannot exist. So this kind of answers the question that y'all had asked a second ago. So if I approach 6 from the left, okay, so look over here at 6. If I approach 6 from the left, that means I'm covering the right side. Okay, so everything over there is gone. As I approach 6 from the left, my y value seems to be tracing towards 2. Now remember, I can't see the other part of the graph. So as I approach towards x equals 6, my y is approaching 2. So I'd be like, oh yeah, I have a limit from the left side, it's 2. Oh, I'm sorry, -2, because we're below the x-axis. But my limit here for x approaching 6 would be DNE. Here's why. My limit as x approaches 6 from the right side does not exist. Okay, now think about why. That makes sense, right? If I move my little ruler to be covering the other side, then I'm like, ooh, where'd that though? Okay, the graph is gone. So I don't know where the limit is because there's nothing there. So my left side limit can be a number while my right side limit doesn't exist, but that messes up this limit as well, because remember, they have to match. Okay? Now, kind of answering the question that we had before about open and closed dots, what would we say f of 6 is? Let's go with Michelle. What would f of 6 be for this graph?
I do not know.
That's okay. So f of 6 is going to be your y value. So if I'm looking at 6, I can see my graph here. I would be at a height of -2. So if it's regular f of a number, you're looking for a closed dot. Okay? So what would f of, is it on here? What would f of 2 be for the graph?
1.
Correct, Sunny, it would be 1, because that's where my closed dot is. Okay, versus an open dot, you're just saying like, this is where I'm going towards, but there's actually nothing there, surprise, okay? All right, let's do the next one. So we want -7, x approaching -7, but the little plus means from the right side. So I take my ruler. Remember, if I want the right side, I'm covering up the left side. And so if I'm looking at that, I don't even know if that's the endpoint, right? Because I'm only looking at 1/2 of the graph. So as I trace my graph closer and closer and closer to that -7, closer and closer, I can see that my height is at about 2. So I would say my right side limit is 2. But then when I move to this limit, see how the little plus minus here is gone? Okay, that means that it's a 2-sided limit. And remember that a two-sided limit can only exist if the left and the right limits are the same. So my right limit was 2, but now let's check our left limit. Okay, where's the graph at? It's not there. So I would say that one doesn't exist. Well, then that messes this whole thing up. Okay? All right, so Jordan, answer my next question for me. What is f of -7? Looking at that graph. F of -7. Okay, so 2 is an open circle. We want a closed circle.
Oh,
So-
okay. 34?
Yeah, it looks like it might be like at 4.5. We'll just say. Yeah. So
Okay.
remember that y values are always going to be your closed dots. Open dots don't count for that. Okay. Good job. All right. So next one, we want x approaching 4 with a little minus. That means the left side. So I'm going to cover up the right side of 4. Okay, right here. And then I'm going to look at my graph. Okay, so we're on this question right here, 4 from the left. I've covered up the right side. Let's take a look at what's going on. As I trace my graph from the left side, remember that a limit means that your y values are approaching a specific number. Now, I don't know if you can tell from this graph, but that's supposed to be an asymptote. Okay, so as I'm looking at this graph here, it's not actually approaching a specific number. It's just like shooting up to infinity. So what you would say for that is that that limit is DNE. Okay? And the reason why is because your y values are not approaching a specific value. They're increasing forever and ever and ever to infinity. Now, here's the other thing that you are allowed to do. Okay, look down here. These two guys go together. Okay, it is true to say your limit doesn't exist, but it is also possible to say that your limit is going to infinity, and that's because your vertical asymptote is pointing up. Okay, your vertical asymptote is pointing up. So there are actually 2 ways that you could write that would be correct. You would say, you know what, limit, it doesn't have one. Or you could say, well, the limits, it's going to infinity. So you're allowed to say either one of those. The AP test does use both. But if it was a free response, they'd accept both. So you should know that it's correct to say the limit doesn't exist from the left side, but it's also correct to say, well, it doesn't exist, but it's going to infinity. So that gives us a little bit of information because we know it's an asymptote, versus if you just put DNE, there could have been a break in the graph, it could have been an endpoint. So this answer leaves you with maybe like a lot more questions, versus this answer tells you specifically what's happening. I have an asymptote on the left side, and it's going up. Okay? All right, so now let's do the right side. So this time we want 4 from the positive side, which would be from the right side. So I'm going to come up to my graph, cover up to the left of 4. Okay, notice all this part of the graph is gone. You can't even see it. Okay, it's invisible. Nobody knows where it is. Okay, I'm only looking at this other side. We'll look at your graph. Okay, are my y values, as I get closer and closer to 4, are they approaching a specific number? Okay, well, again, that's supposed to be an asymptote. So your answer would be, well, no, they're not going to a specific number. They're just going down forever and ever and ever because I have an asymptote. So you have 2 correct answers. The first one would be DNE. Any guesses at what you would put for the second one? Would I put infinity again?
Negative infinity.
Here we go. That's right. Okay, it'd be negative infinity because your asymptote, I'm going to abbreviate that, VA, is going down. Okay, so you can say that an asymptote's limit is positive infinity if it's going up, negative infinity if it's going down. Okay, but then for your x approaching 4, If my left and right limits don't exist, this limit doesn't exist. Okay, but could I say that this limit equals infinity? Like I did on the other two? Take a guess.
No, because they're not equal.
They're not the same infinity, that's right. Okay, so if one of them's a positive infinity and the other one's a positive infinity, I could play this game and be like, oh, it's infinity. But if one of them's positive and the other one's negative, your only allowed answer would be D&E. Okay? Because those limits do not match each other. I'm going to peek at what we're doing next. Okay, any questions about that? Oh, we have a chat. What's the question? Oh, it's all good. Can I explain? Okay, so what I'm going to have you do now is turn to the next page if you have your notes. And then I want you to do those top 6 questions, okay? And then Loretta, the end point, just to explain that to you, if you're doing 2 from the left, okay, so I'd be covering the, let's see, you said this one right here, right? Oh no, it was the end point. So that would be this one, I think. So when you cover up your end point as x approaches 6, so from the left side, I can see that I have graph here. And so I can trace it and be like, okay, well, as I get closer to 6, my y value is -2. But then when I check it from the other side, there's no graph. I have nothing to trace. So what you would say is I have a left side at 6, because when I cover the right side, I see graph and it's going towards -2. But as I slide my ruler over to the other side to check 6, there's nothing there. So at an endpoint, you can have a one-sided limit, but your other side doesn't have any graph there. So you would say that this limit, where you take the little plus minus off, the two-sided limit, that limit doesn't exist. Okay? And then for your, for the first question for number 1, if you're doing 2 from the left, you'd cover up the right side and you just trace that graph. So as I get closer and closer here to 2, my y values are getting closer and closer to 1. Because remember, I can't even see this chunk over here. Okay, you said that backwards in the chat, Loretta. When you cover the left, when you come from the left side, you're covering the right side. You're covering basically the opposite half. Make sense? Okay. All right, if you were waiting, the questions are now on the thing. So I'm gonna give you a sec to do it. Okay, the top row, you're answering questions about F. Bottom row, you're answering questions about G. And when we get to the bottom of this page, we're gonna start your homework. So when you're looking at your y, you're always gonna use the closed circle. Okay, so Jakayla, the answer to the question was, when you're looking at your y, you're always using the closed circle. If it's f of a number, you're gonna use your closed circle. So let me actually, if you already did the top row, awesome. If you didn't, Jakayla, I'm gonna try to explain your question now. So if I'm doing 2 from the left, I'm covering up the right side, okay, because remember we said you're always covering up the opposite side. So everything after 2 on the graph is gone. I'm looking at where my graph is headed. So I'm not actually caring about if it's an open or closed circle. So I'm looking right here. As I get closer to my ruler, my y value is staying a 3. Okay, then I'm coming over from the other side now. I want a right side. Okay, and remember, I don't care what's over here. I'm only caring about this side of the graph. I'm tracing closer and closer to the ruler. My y value is approaching 2. I think the question that you're asking is, what if I wanted f of 2? F of 2, I would always choose the closed circle. So for limits, you're covering each half of the graph, and tracing closer to that X value. Okay, but if you're doing F at a number, you care if it's open or closed. But for limits, technically, you're kind of covering up those dots anyway, right, when you cover up each half. So F of 2 for this one would be 3, because that would be your closed dot. Okay, but for limits, the dot actually does not matter. Okay, and then spoiler alert here, but X approaching 2 would be D, N, E. Okay, because my left side was 3, my right side was 2, not gonna work. Okay, I'll give you one more sec to do 4, 5, 6. Let's go with Lucas. When you're ready, what is the left side limit for -1 on the graph of G? Lucas.
1.
It is 1, correct. Okay, so cover up the right side. Remember, those dots are gone. As I trace closer and closer, I'm at a height of 1. Okay, let's find another little friend that wants to talk. Mr. Tubbs. Okay, Robert, as I cover the right side of my graph, what is my limit as X approaches -1 from the right side? What would that be?
-2.
Correct. Very good. And if my left side is 1, but my right side is -2, overall, that's a DNE. Make sense? Okay, so next one, I want to know if the limit as X approaches 1 of f of X exists. If not, explain why using the definition of a limit. Okay, so remember, the definition of a limit is that that limit only exists if the left and right sides match. So I would say, okay, well, let me take a look at this graph at 1. Okay, what's my left side? Let's cover it up. Okay, my left side looks like it's headed to what Y value?
1.
Correct. What about my right side?
Also 1.
Now, right side, I can't even see any of this, right? So I'd have to be on this next little chunk right here. And as I trace closer and closer to the ruler, what's my Y value from the right side?
3.
So if my left side is 1 and my right side is 3, I would say here, this limit is a DNE because. Now, all of your AP classes have a writing portion. Okay, the AP exam does too. So you would be expected to explain this using math, not like using words. So you would say the limit as X approaches 1 from the left is 1, but the limit as X approaches 1 from the right is 3. So the definition is that if those match, my limit exists. Well, then if I'm saying the limit doesn't exist, I need to explain why by showing that my left and right limits were not the same. Okay? Does that make sense? Okay. So we have one last thing to look at, and this is where you do your limits in reverse, okay? So what that means is they're saying here, list all possible values of A for, to make the following limit statements true. Okay, so notice A is what my X is approaching, but they're telling me that they want the limit to equal 4. So, okay, this is the Y value that I want. Okay, that's the Y value that's wanted. I want that Y value. So if I'm looking at the graph of F, I'm going to draw in a line at 4. And then I'm going to check for any X values where my left and right side are both approaching 4. So the first one that I noticed where I could put my ruler, right, they're asking for the X, would be here at -2. because my left side and my right side both would give me that y value of -4. So I'm going to put a could be -2, and there's one more, but you're going to have to extend your graph here. Okay, the other place would be here at 4. Because if I cover up my left side, or I'm sorry, if I cover up my right side and check the left, cover up the left and check the right, both of those sides are 4. Okay, so those would both be 4. Now let's go to the next one. So the first one was easy. Now I want to know, what would x be approaching, what a value, so that my limit would be 1. So let's draw in a line here at 1. Okay, it hits my graph twice, but I have to think about, I don't just want the answer to be 1, I want the limit to be 1. So for this breakpoint here, if I cut my graph in half, I have a 1 on the left, check. I have a 1 on the right, check. That means that -1 is an answer for A. Okay, but then I notice my other point over here. I'm like, okay, well, my left side is a 1, but what's my right side? Is it also 1? What's my right side there? 3. So then can I say that this limit would have equaled 1? No. So I would be like, nope, doesn't count. So I have the limit to be 1 at -1, but that does not happen at 1, because remember, both sides have to match, okay? And then that next question is exactly the same, so you can just skip it. Okay, so we have one more little row here. Now we're using the graph of, oh, these should have all been G's. Will you change that on your notes? That whole bottom row, we should be using the G graph. Okay. Okay, so I want to start with this one. We're going to go out of order here. Okay, so first one, if I want my limit to equal -3, I'm going to come into my graph here. I'm going to draw a flat line through -3. I see a touch point here at 0, but then remember, I have to check the left and the right sides to make sure they're both -3. Okay, so I'm going to check it from the left. I see that it's approaching -3. Check it from the right. I see it's approaching -3. That's good news. So I know that A can be 0, because remember, that's an X value. They're giving you the Y value that they want right here. Okay, so they're giving you the Y, you're telling them the X. Okay, so let me give you a sec to do this one. We're doing this one next. So I want the limit of G to equal -2. And I want you to tell me where, if anywhere, that happens. So there's -2. I see 2 places that it touches, but will both of them count to make that statement true? Oh, it's 10. No. Okay, we'll finish on Monday. I'm sorry. I didn't realize we were so close on time. Y'all have the best day. Make sure you put your name in the chat, okay? And then I'll send you your homework. You can start on it if you want to, but you can always wait. You'll have several days to do it next week. Okay? Sunny, the homework is on Google Classroom under the notes. But I'll send out a remind with very clear instructions. I'm sorry, my clock is wrong by like 10 minutes, so. Have a good day, bye.